It was a revelation that stunned the world. Voyager 2, the oldest functioning probe ever launched by humanity, had suddenly gone silent, vanishing into the vast, dark reaches of interstellar space. Billions of miles from Earth, the spacecraft ceased all communication. For nearly 2 weeks, NASA searched desperately for any sign that the 46-year-old emissary of Earth was still alive. Then, on an otherwise ordinary day in August 2023, something extraordinary happened. A faint signal, a distant whisper, echoed back from the edge of the cosmos. What NASA would soon uncover would not only astonish the global scientific community, but forever shift our understanding of space and our place within it. Over 13 billion miles from Earth, Voyager 2 continued its lonely trek through the stars. For more than 4.5 decades, the spacecraft, built with technology older than most people alive today, had carried with it a golden record, a symbolic message in a bottle containing sounds of nature, music, and greetings in over 50 languages. It was humanity's handshake to the universe. But in July 2023, that message appeared lost. For 14 agonizing days, Voyager 2, the farthest and oldest active spacecraft in existence, went dark. The steady stream of data that had flowed since its 1977 launch halted without warning. NASA engineers stared in disbelief as their screens fell silent. No backup probes were nearby, no repair missions possible, no second chances. Voyager 2 was adrift, untouched by human hands, uncontactable by any voice from Earth. Then, against all odds, came the breakthrough. Amid the background noise of deep space, a tiny blip, a pulse so faint was nearly missed, reached Earth. It was like a heartbeat from across the void. Voyager 2 was still there. Barely, but it was alive. Around the world. Hearts skipped a beat as NASA prepared one of the boldest rescue attempts in the history of space exploration. This was more than just an effort to revive aging hardware. It was a fight to preserve our voice among the stars, our legacy, our dreams, our enduring curiosity. To understand why Voyager 2's near loss struck such a deep chord, we must return to the summer of 1977, a time of bell bottoms, the debut of Star Wars, and a rare planetary alignment that would only occur once every 175 years. Scientists dubbed it the Grand Tour and allowed a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune in one epic journey. Voyager 2 launched from Cape Canaveral on August 20th, 1977, followed 2 weeks later by its twin, Voyager 1. Originally, the mission was meant to last just 4 years, a modest exploration to gas giants. No one imagined these probes would still be functioning nearly 5 decades later, or that they'd become the first human-made objects to exit the solar system. Each Voyager was about the size of a compact car, yet their computing power was minuscule, only 69 kilobytes of memory, less than what's needed to load a modern web page. Despite that, they carried out one of the most ambitious scientific missions in human history. One of the Voyager's most iconic features was a golden record, a 12-inch gold-plated copper disc encoded with 115 photographs of Earth, natural sounds, music from diverse cultures, and greetings in multiple languages. This record was meant to represent life on Earth to any intelligent being that might one day find it, a time capsule adrift in the ocean of stars. Voyager 2 went farther than anyone dreamed. It remains the only spacecraft to have visited all 4 outer planets. It discovered volcanic activity on Jupiter's moon Io, revealed the complexity of Saturn's rings, and provided humanity's first up-close looks at Uranus and Neptune. Then, on July 21st, 2023, after nearly 46 years of near-flawless performance, something went terribly wrong. NASA's Jet Propulsion Laboratory had sent routine commands to adjust Voyager 2's orientation. Routine commands were sent to Voyager 2, simple alignment tweaks and system checks, the kind executed thousands of times before. But this time, something went wrong. The spacecraft high-gain antenna, its primary communication lifeline, tilted just 2 degrees off its intended orientation. That may seem trivial, about the width of thumb held at arm's length, but when you're trying to transmit across nearly 13 billion miles of space, that tiny misalignment spells catastrophe. Imagine aiming a laser pointer from Earth and trying to hit a coin on the moon. That's the level of precision required. The moment the antenna veered off course, the signal vanished. Voyager 2 went dark. NASA's mission team was suddenly staring at a chilling scenario. There were no backup satellites nearby, no onboard cameras to assess the problem, no astronauts to dispatch, no physical fix. Voyager 2, humanity's emissary to the stars, was now adrift in interstellar space, mute and unreachable. Suzanne Dodd, Voyager's project manager, confessed to a terrifying fear. They might never hear from it again. And that possibility carried enormous weight. Almost 50 years of unmatched engineering and discovery, now possibly silenced forever. The timing made it worse. Voyager 2 had been transmitting one-of-a-kind data from the uncharted edges of interstellar space, measurement of cosmic radiation, plasma densities, and magnetic fields that no human-made object had ever gathered before. Every signal was a treasure trove of knowledge we might never reclaim, not for centuries, if ever. And now that stream had gone cold. For nearly 2 agonizing weeks, 11 long days, NASA's Deep Space Network sprang into action. Massive radio antenna arrays in California, Spain, and Australia scanned the heavens. These dishes, some the size of stadiums, serve as Earth's ears, straining to catch even the faintest whisper from the void. Engineers worked around the clock, recalibrating frequencies, tweaking systems, searching desperately for a trace of Voyager's voice among the cosmic static. But all they received was silence. Profound and absolute, the challenge was monumental. By 2023, Voyager 2's transmitter was operating at a mere 23 watts, the power of a refrigerator bulb. That signal, crossing 13 billion miles, will arrive on Earth billions of times weaker than a watch battery. Capturing it was like trying to hear a whisper from New York while standing in Los Angeles. And with the antenna now misaligned, the signal was dimmer still, perhaps loss of good. As days turned to nights, the silence deepened. Hope began to fade. Had Voyager 2 finally succumbed to the wear of time and radiation? Had its power dropped below critical thresholds? Was this the end of its extraordinary journey? For NASA, and for countless people around the world, this wasn't just a potential loss of a spacecraft. It was a possible loss of a symbol, a testament to humanity's curiosity, determination, and capacity to reach beyond the imaginable. And while Voyager 2 drifted silently, a different mystery unfolded with its twin, Voyager 1. In late 2017, engineers noticed something strange. Data from Voyager 1's ACS, the Attitude Articulation and Control Subsystem, indicated the spacecraft's antenna was pointing in a direction that should have severed communications. Yet, contact remained clear and strong. It was as if someone claimed to be calling from the South Pole, but your phone's GPS said they were standing outside your door. Engineers first attributed the glitch to aging equipment. After all, the probe was built in the 1970s and had survived more than 4 decades in the harshest environment known. But even after issuing diagnostic commands, the anomaly remained. Months of analysis led to a bizarre conclusion. Voyager 1 appeared to be existing in 2 different orientations simultaneously. Clear signals, impossible readings. Though Voyager 2's communications remained strong, its internal systems began reporting anomalies, readings that defied logic. Then, in 2023, the mystery deepened. The spacecraft's plasma wave sensors started detecting persistent, repeating waveforms unlike anything recorded before. These weren't random bursts of cosmic noise. They followed structured mathematical patterns with distinct frequency relationships. The signals would appear for several hours, vanish, and then return with slight variations, as if Voyager were passing through carefully ordered, almost engineered regions of space. Some scientists liken the phenomenon to standing waves in the interstellar medium, akin to the harmonics produced when a guitar string vibrates. Others propose more exotic theories. Perhaps Voyager had entered one of the invisible filaments of the cosmic web, the vast, ghostly lattice that connects galaxies. Yet none of these theories fully accounted for the consistency or precision of the signals. Could these be the first faint traces of something unknown, something intelligent, taking notice of our distant emissary? Heat signatures from the void. In early 2024, Voyager 1 introduced a new enigma. Temperature sensors, long dormant since the probe's planetary flybys. suddenly came to life, registering thermal fluctuations that defied expectation. These sensors, and used for decades and expected to reflect only the frigid vacuum of space, just 3 degrees above absolute zero, began showing regular spikes, up to 30 degrees Fahrenheit, every 4.8 to 8 hours. Then the temperature would gradually return to normal, only for the pattern to repeat again and again. Even more astonishing, these heat pulses coincided perfectly with the electromagnetic oscillations detected months earlier. Multiple systems, once thought disconnected, were now reacting in synchrony. NASA launched exhaustive diagnostics. Could decaying heat from the onboard radioisotope generator explain the rhythm? Was it electrical interference? Or some feedback loop? One by one, every internal source was ruled out. Only one explanation remained. Voyager was encountering a structured external energy source, something with rhythm, precision, and intent. Even stranger, amid these thermal stresses, the spacecraft's power systems began to improve. Power usage became more efficient, far beyond what its aging programming should have allowed. It was as if something unknown was both straining and supporting the probe, like a car overheating on a long drive, but somehow getting better mileage at the same time. Voyager's simultaneous deterioration and optimization defied all logic. The countdown begins. Despite the miracles, Voyager 2 is dying. It runs on a radioisotope thermoelectric generator powered by decaying plutonium-238. Every year, it loses roughly 4 watts of power. That may seem trivial, but when you're operating on the energy equivalent of a nightlight, every watt counts. NASA has been forced to make painful decisions. In October 2024, the Plasma Science Instrument, once vital for studying the solar wind and interstellar plasma, was turned off. In March 2025, the Low-Energy Particle Detector, which had been collecting cosmic ray data since the late 1970s, was also shut down. Now, only 3 instruments remain: the magnetometer, the plasma wave antenna, and the cosmic ray telescope. These final tools may continue into the early 2030s, if everything holds together perfectly. Eventually, however, the RTG will no longer generate enough power. The transmitter will fall silent. The onboard computer will shut down. And for the first time since its launch on August 20th, 1977, Earth will lose contact with its most distant voice. Repairs across a light day. Perhaps the most astonishing part of Voyager 2's journey is this. Every fix, every patch, every reboot has been done remotely from 12.9 billion miles away. Each command takes nearly 20 hours to reach the spacecraft. There's no live feedback, no real-time adjustments. Every correction is a leap of faith, a whisper cast across the vastness of space. And yet, for nearly 50 years, it has worked.